Welcome, everybody. We're thrilled to have you here with us today for today's webinar. And today's webinar is focusing on grips and fixtures for compression, tensile, and torque testing. But before we dive in, there are a couple of housekeeping notes I'd like to share with you. So today's session is brought to you by Mecmesin, a proud member of the Physical Properties Testers Group. PPT Group is a collective of leading brands in the field of physical properties testing, offering a wide array of solutions for tensile testing, compressive strength testing, torque testing, textile testing and analysis, and the effects of shock and vibration, amongst other parameters. Our sister companies within the PPT family include Landsmont, James Hill, and Aluris. And for more details about the group and all of the brands within the group, please visit the PPT website. I've already shared a link to our events page on the PPT site for you in the chat box. So you're welcome just to click on that link just to take a look at that. Now, just focusing on Mecmesin, we have established technology labs across the US, UK, and Asia, dedicated to supporting our customers with education, proof of concept, and demonstration testing. So should you have any specific needs in physical properties testing, our global team is at your disposal to provide assistance. But let me introduce the team for today's webinar. Moses DeRocha will again be our presenter, and I'm Sharon Smorenberg, one of the coordinators behind the scenes. Additionally, we have support staff and partners stationed across Asia, Africa, Europe, and the Americas, ensuring that no matter where you are, we have a local expert ready to support you. We hope again to have a dynamic and engaging webinar, so we'd encourage you to participate through questions. Feel free to submit any questions you have at any point during the webinar using the question box. We will then address these questions at the end. The webinar is being recorded as always, and it will be emailed to you probably tomorrow to the email address with which you registered. And please feel free to share this webinar with any colleagues you think might be interested, or just to keep it on record for your own reference. And now, without any further ado, I'll hand it over to Moses.
Thanks, Sharon, and thanks everybody for making our webinar today. As Sharon's already introduced, this is usually a three-part webinar. As in, we usually delve into grips and fixtures for just tensile testing, grips and fixtures for just compression testing, and then grips and fixtures for torque testing. Since this is essentially, well, pun intended, essentials of, it's more of an introductory. At sometime later this year or early next year, we'll look at these in a little bit more in depth at looking at the different types of applications under compression testing, tensile testing, and also torque testing, so we can kind of get a better grasp of what any of these fixtures represent, what to use and why. But to reiterate, today's is more of an introductory essentials to take a cursory look at the common fixtures and grips that are used in tensile, compression, and torque testing. So our agenda for today will be quite simple. We'll look at some of the critical elements of repeatability and consistency. Now, we know the selection of grips and fixtures play a crucial role in establishing a consistent and repeatable testing environment. And so we'll look at what some of those elements are. And then obviously the importance of grips and fixtures in testing in general. And then we'll hone in on what to use and why for compression, for tensile, and for torque testing. So the key factors that are usually required for any consistent and repeatable testing environment are obviously defining a testing objective. And as in, why are you even testing a product at all? What are you looking for? Obviously, without a destination, you're not going anywhere, right? So we need an objective why that test is being performed. And then establishing a testing standard requirement, or how do you go about meeting that objective? So let's just say we're looking for the compressive strength of a container. we've defined the objective. How do we go about compressing that? Is there an existing ASTM or ISO standard that kind of gives you a guide on the types of fixtures to use, sample preparation, the testing environment, and so on, the speed of the test, what kind of data to include in the calculations, and so on? Or is it just an in-house standard where you're establishing your own testing parameters? And then once those questions are answered, the next step is to determine the appropriate testing equipment to use. Are we using a handheld unit? Is it going to be a simple motorized unit? Is it going to be a computer controlled unit? Again, depending on the sophistication of the testing application, you can determine what type of equipment to use. Other factors that go into that selection are also how much force is being applied in the test, how much elongation is expected, and things like that. And then right below that, just as equally important, is the ideal grips and fixtures and the role they play in establishing this repeatable testing environment. And then also, once these are done, you have to develop an SOP or a standard operating procedure for operators and stuff. Because what happens once you've determined your testing objective and you know why you're testing and what you're using for your testing as far as testing equipment and fixtures, the next thing is the only way any variation can creep into the process is if all the operators are not doing the exact same things each time for the test. So we have to determine our sample sizes are going to be, let's say, 6 inches by 4 inches at all times. We're going to maintain, let's say, 72 degrees in the testing environment at all times. We're going to make sure that all operators are fixturing the samples the exact same way. We're testing the same batch of test samples at this, so it's things like that that need to be developed, so just to ensure that we're enhancing consistency in the process and all operators are doing the exact same things at all times. And then obviously, once any of these fails, if after all of these you still see any inconsistencies in the product, then or the test results, then it's always okay to go back and check for actual product or sample anomalies, as in, hey, what's going on, what's coming down the line that may not conform to whatever your required standards are. So in all of these, as I said, any one of these can be its own webinar, but we'll focus primarily on number 4, which is the ideal grips and fixtures and how important they are to establishing a consistent and repeatable testing environment. So how important are these fixtures and grips to your testing, as far as whether it's compression testing, tensile testing, or torque testing? So we'll start with the accuracy. The right grips and fixtures can minimize the variations and inaccuracies in your testing measurements, right? And so, for example, if you have a 6-inch wide sample, it wouldn't make sense using a 4-inch wide grip to grip it because you have the overhang, which might affect the actual accuracy in your testing, right? Or if you're testing film and you're gripping it with serrated jaws, those jaws might bite into the film. And so the tear or the break happens at the point of contact and not necessarily in the middle where you expect it to be. So again, selecting the ideal grips, critically important. Again, and once you find the right grip, you're enhancing the repeatability, right? So if it's the right grip, then it means as long as the operators are fixturing the samples the exact same way, you should see some consistency in the test results, as in the test being repeatable. Gripping the sample correctly is essential for test repeatability. Ease of use. This is a factor that we usually don't really take. Now, we don't want the operator with the biggest forearms to be the only guy that's able to fixture a certain sample correctly. We want the ideal grip to kind of lend itself to ease of use, regardless of who the operator is. Again, all in the SOPs, if everyone's doing the exact same thing at all times, then we shouldn't have one operator, over tightening, another person under tightening. If that is a problem, then you probably should go with a lever operated or a pneumatic style grip, which will ensure all operators are fixturing those grips the exact same way. And then finally, sample stability. When a sample is under tensile or compressive test or in a torque test, the worst thing that could happen that could really create some variability in your results is if the sample is moving or slipping or wobbling while the sample is under any kind of compressive or tensile load. And so you want to make sure when you grip samples that they will remain steady to prevent any variations in your data. So these are the important factors that go into the role that grips and fixtures play in your testing application. So we'll take a quick look at some of the common or the commonly used grips and fixtures in compression testing. Now, as I mentioned previously, these are usually a whole webinar on its own, whole hour. That's when we delve into the types of compressive testing, and then we look at what to use and why specifically and so on. But as I said, this is going to be more of a cursory, general, introductory look. So compression or push testing usually can be either destructive or non-destructive testing. It essentially measures force resistance when you compress to a known deflection or displacement. So these are the three types of tests that you usually would see in a compressive test, where you compress to say 2 inches and then measure the maximum force resistance, or you can measure the deflection when a specific force is applied. So if you wanted to say test a spring and you want to know how much that spring deflected at say under 20 pounds of load, that would be one of the objectives of a compression test. And then there are other instances where you can just run until the sample breaks or fails, and then we can measure one or both of two things, which is either the force at break or the deflection at break, or both, and so on. So you're measuring the sample yield or point of deformation or failure in addition to break and or deflection. So these are some of the objectives in a compressive test, as you can see from those images there. In a more comprehensive discussion of compressive style testing, you see spring compression testing, burst testing, needle penetration testing, 3-point bend, crush testing, top load testing, and so on. So what are some of the grips and fixtures that are used in these applications? We'll start first and foremost in typical top load or crush testing. And these would involve compression plates, or you might hear the term platen used every now and then. Now, these come in different sizes and materials. They can be round, square, or rectangular, depending on the type of samples being compressed. And they can also be rubber-faced. Rubber-faced compression plates prevent slippages, especially when you're compressing really smooth samples, because anytime that plate slips, it might create a certain anomaly in the test result, which is undesired. And then you can also have a self-leveling or cone-pointed types of compression plates, which self-leveling kind of self-explanatory. If you have uneven surfaces, a self-leveling compression plate is usually ideal. And then the cone point is if you have samples where you need that cone to enter the opening of the container and also to let air out so you're not building up pressure in that bottle. That would be ideal as well. Some of the test applications that you might see using round, square, rectangular, vented or non-vented compression platens would be top load testing. You'd find top load testing in blow molding or in other containers and so on, whether it's aluminum containers, cans, plastics, and so on. And also burst or break testing. You can also do some push out testing, which these are all the common applications that you would essentially identify these types of compression plates in. There are also compression probes that are more specific when you want to kind of pinpoint more of a specific areas instead of compressing on general areas. In general areas, that's when you would use a plate. The probes kind of run a similar, they perform a similar role, but slightly different. Again, you'll find these in different sizes. These are when you're doing a burst test or break or puncture test or an insertion test and so on. You'll find these types of probes, either steel, aluminum, plastic, and then you can see these in either flat, round, radiused, or sharp edges. Again, you'll see these. Imagine if you had to test the keys on a computer keyboard. Compression plate might be touching several keys at once. So using one of these more dedicated probes would be able to concentrate on just one key at a time. Or if you had to do a needle puncture, if you had to puncture leather or rubber or textile, then one of these, a sharp tip probes would be more ideal for that testing application. If you had to do a burst test through plastic or paper, then the radius or the round ball probes would also be more ideal. So some of the testing applications you might encounter with these fixtures would be touch pads, screen testing, touchscreen testing, puncture, penetration, push out testing, crush or burst testing, and so on. Next, there are also certain custom applications. These are the ones that are usually not simply off the shelf, but they're customized to meet specific testing standards, or maybe just because of the size of the sample, just hanging a compression plate on a load cell might be a little too much. So these are the times when you might go to, say, a guided rod style compression platen assembly, like you're looking at here. If you had to do an ECT or a BCT box crush test application where you put in the whole carton in your testing area, the image you're looking at would be kind of a typical fixture you might encounter. These are the compression platen assembly with guided rods. So you're not exerting too much force on the load cell that's applying the actual compression. So these will also come in different sizes and materials. You can have round or square or rectangular. And you could also have static, static as in they're more dedicated, and then the quick change adapters allow you to change between fixtures relatively quickly. So if you could imagine having different sizes of boxes that you had to test, you could essentially keep the same base plate and probably change the top sizes and so on. Again, as previously mentioned, you'll find the types, custom test applications being carton, crush testing, glass or brake testing, and then you can have some touch actuation testing as well. All right, so types of grips and fixtures in tensile or pull testing. Now, as we've previously mentioned, again, this is a whole webinar on its own, but we'll look at some of the factors or features of tensile testing. Again, these can be destructive or non-destructive testing that also measures forces at either a specific displacement or measures the displacement or deflection when a specific force is applied, and also measures the force when the sample fails or breaks, or the point of deformation. So again, in certain force testing applications, running to a tensile displacement and measuring the force is common, or applying a specific tensile load and then measuring the stretch is also common. But when you're testing for materials, there are usually additional calculations like the yield point of deformation, the elongation. You'll find a whole bunch of other fancy calculations like Poisson's ratio or modulus of elasticity and so on. So in any of those, regardless of what the testing application requirements call for, whether it's an in-house testing standard or an ASTM standard or an ISO standard, the grips and fixtures will always be pretty much the same. So a quick look at some of the grips and fixtures. The most commonly used grips and fixtures in tensile testing are wedge grips. What's the allure of wedge grips? The grips are lever operated or capstan operated, but they're mostly spring loaded. And so the jaws tighten as you pull on the sample. And the reason for that is to address one of the important factors of grip selection, which is preventing the sample from slipping as you apply any kind of load, in this case, tensile load. So lever operated, spring loaded, or spring operated or wedge grips are commonly used, or the capstan, the way you have that wheel turn, is also commonly used. So especially in tensile applications that require slightly higher rates of force and so on. Now, again, these come in different sizes and capacities, depending on a few things. One, what the sample width is and sample thickness, as well as how much force is required in the testing application. These can be aluminum or steel, and you can have one of the added advantages is also you can have multiple jaw faces depending on the sample material. Is it leather? Is it rubber? Is it textile? Is it metal? Is it soft aluminum? Is it paper? Is it film? So you can have things like just a flat faced or rubber faces or serrated jaw faces, or even when you're pulling on round samples, if you can imagine a stainless steel rod, you have V groove jaws that form around the round samples to prevent the samples from slipping. And again, they can either be lever operated or spring loaded. And in many of these different fixtures, you can have manual or pneumatic operated fixtures. Now, that can be designed for both round and flat samples. Typical testing applications will be your ASTM D638, the tensile or pull test, or a tear test, peel and adhesion strength testing, pull out or tension testing, and so on. Now, the few limitations that you would encounter with wedge grips is that there are limitations on the width of the samples that you could test. So imagine the maximum of some of these jaws are about 50 millimeters, of almost 2 inches in width. Anything more than that, if you had to test a sample and say that's about 4 inches in wide or 6 inches wide, then you might want to be looking at Vise grips. Now, Vise grips also come in different sizes and capacities depending on what the application requirements are, the type of product you're testing. Again, they can be aluminum or steel. Are you testing flat or using rubber faces, serrated faces, or even wave faces? So imagine if you had to test a piece of textile or fabric. There are these wavy kind of jaws that kind of interlink. So when you put your fabric in it, it kind of interlocks the fabric and kind of pushes and all the energy and concentrates the braking force to the middle, which is where you want it to be. Again, these can be used for both narrow and wide samples. And I've seen samples go as far as 8 inches in width. Again, that's something that wedge grips cannot accommodate. And you can also find Vise grips in either manually operated lever or dual screw, or they can also be pneumatic, as in air controlled, especially where you need to really clamp these products and prevent them from slipping while they're under load. And again, Vise grips are designed for both round and flat samples. Samples can be rigid, samples can be soft, but those will all essentially determine the types of jaw faces that you are using in that testing application. Okay, so again, typical testing applications will also be tensile, pull or tear tests, peel and adhesion strength testing, pull out testing, shear testing, tensile shear testing, and so on. There are other common tensile testing fixtures, things like test hooks that are very simple. Essentially, if you bought a simple force gauge, more than likely in that carrying case, you would have a simple test hook that can be used for very simple pulling applications. Or you might have a flip cap hook that's used in any of the products that are in your refrigerator, the flip cap. So we call that a flip cap accessory or flip cap hook that's used in testing the strength it takes to essentially flip the cap to open to access whether it's a beverage or sauce or dressing or what have you. And then there are cam grips that are also used in different types of tensile testing. There are bollard grips. Bollard grips are super cool in especially yarn or rope or wire testing, where it allows you to kind of essentially wrap the wire around the bollard, which transfers the energy to the center, because you don't want the wires breaking at the point of contact where the jaws come into contact with it. And so by wrapping it around the bollard, you essentially transfer the energy to the center or the middle of the sample, so it breaks right in the middle. And then there are these crimp receptacles that are used in crimp strength testing on cables and wires. So you could essentially on one grip have different sizes of cables, anywhere from 28 gauge down to 6 gauge, where you just rotate the center to get the right slot to essentially accommodate the wire in order to kind of, again, concentrate all the force on the actual crimp removal and not on the wire itself. So different testing applications where you would find these types of fixtures being used are loop strength testing, which is for the test hooks, flip cap test, strength testing for the flip cap hook, film and tension, in those cam grips. Now, the cam grips, you could get those in either serrated faces or smooth faces, depending on the type of testing application. Ropes, wires, yarn, cable crimp connectors, and also certain pull-out or pull-off testing applications. Now, there are also certain application-specific custom and 3D printed fixtures that can be used, and I'll talk you all through all of them here. So let's start with that multi-jaw grip there. It's one of the super fancy, cool fixtures that we have for, so if you think of, say, a teddy bear eye on your plush toy or your stuffed animal, one of the tests we perform is to see how strong or how strongly sewn on the eyes on those plush animals or stuffed animals are. And essentially to grip that, which simulates a child kind of putting that button or that eye in their mouth and then testing the strength to make sure it does not become a choking hazard. So it's sewn on strong enough. So by using this multi-jaw grip, it essentially forms around the button or the eye. And if you tighten that, it will grip it as if you were kind of simulating gripping that between your upper and lower teeth, front teeth, and then pulling on that. We also use that for button pull off or eye pull off or what have you. And then there are the floating peel jigs that are used to remove the lamination off of credit cards, IDs, and so on. And then there's the floated and assisted peel testing, which allows you to do 90-degree peel and adhesion testing to certain ASTM testing standards and so on. And then for applications that require really low or minimal force, or in instances where it's such a unique application, there's nothing off the shelf that actually meets that application requirement, we're able to generate 3D printed parts. One of the advantages of a 3D printed part is if it's a really low force testing application, you don't want to put a hunk of a grip or fixture on there, which kind of exerts too much force on the load cell. So a 3D printed part allows you to kind of dabble into lighter material while still not deviating from the accuracy of the testing application. So they're 3D printed parts, either for low force applications or for custom applications for which there's nothing off the shelf that actually meets the standards, or for really sophisticated custom concept designs and so on. So I know sometimes we encounter, hey, look, when I was going through your grips accessory here, this is the product we're testing. I can't seem to find any grip or fixture that meets that. Not to worry, we always do custom grips and fixtures all the time. So these are some of the different types of tensile testing fixtures that you would encounter. Our next part here is our closure torque testing. Now, every time I use the word closure torque, or anytime our industry comes up and we mention torque, I know if you're a car enthusiast, the first thing that goes to mind is torque, like vehicle torque. So I'm going to disabuse your mind of that. So for us, torque is essentially going to be either a static or reaction torque. And it comes with anything that turns, whether you're turning it clockwise or turning it counterclockwise. Static torque, as in, how much torque it takes to remove a cap off of your bottle, or reaction torque, how much torque resistance there is in spinning a fan, and so on. So again, a quick overview here is torque. That's the twisting that causes a rotation. In physics and mechanics, torque is essentially the rotational equivalent of what you would see in a linear force. So it's going to be a torque over a certain angle, or force over a certain angle, to determine that torque. Now, the different torque types that you would see would be a static or reaction torque, which involves a slow rotational rate of speed. I did mention, for instance, the amount of torque it takes to, say, turn your wipers on in using the switch that's mounted on your steering column. Whereas the rotational or the rotary or dynamic torque involves the motor that actually controls the wipers or your roll-up windows or your fan and so on, would be more a faster continuous rotational rate of speed. And then most torque is measured either as an application torque, closure or torque to close, or open, release, or removal torque. So these are the types of torque that we usually kind of reference when we're talking about torque testing, and not necessarily vehicle torque, right? Like your Mustang having this much torque and so on. Now, types of torque. Any torque testing application will always start with how the sample is gripped at the base. Now, if it's a container or some other type of fixture or sample, you usually could use a saddle plate. Now, if you look at that image there, the saddle plate is essentially that flat plate that ensures your sample always sits flat at all times. Remember, one of the factors that enhance a repeatable and consistent testing environment is making sure operators are all doing the exact same thing at all times. So using that saddle plate ensures none of the products are kind of hanging, more than the others. If all operators are required to have the sample sit flat before testing, that saddle plate comes into play. Using that V block can also ensure that samples are gripped at the same position at all times. And then precision fixing plates are usually used. And then certain general applications can also use those fixing pegs you're looking at. This is for a more universal torque testing application where you can move those pegs around depending on the sample sizes. So you bring them closer if your sample size is smaller, and then you open them wider if your sample size is wider. Now, the advantage you can get from these types of fixtures is they accommodate round, square, hex, or non-symmetric samples. And these are essentially silicone plated pegs, again, to address that important factor of preventing the sample from sliding or slipping while they're under a certain torque, whether in clockwise or counterclockwise directions. Other types of fixtures that you might encounter would be closure chucks and mandrels. So again, the one of the disadvantages of using the pegs, which we've just alluded to, is it requires a certain amount of tightening where you turn the knob to tighten those pegs around the top and the bottom. Now, depending on how big or strong your operator is, everyone has their own concept of how tightly they're actually tightening those pegs. If you over tighten, you might create an instance where it would require a little bit more torque to release the cap. And if you under tighten, the sample might slip. So those are instances where you would rather opt for chucks and mandrels that are formed specifically for to the cap. Especially in cases where you're testing serrated caps. We can kind of mold or form these in either circular or split or aluminum, plastic, or steel mandrels to fit those specific caps. So if you took your regular soda bottle out of the refrigerator, you could see the serrations on the cap. We can form a mandrel to fit that specifically. The added advantage of that is that chuck, anytime you lower the chuck onto the cap, it fits perfectly, which means all operators, regardless of how big their muscles are, can always, essentially fixture the sample the exact same way every single time. In cases where the caps are smooth, we have that split mandrel. So even though you're tightening, it tightens to form around the cap and kind of minimizes, if not eliminates, the tendency to over tighten. So you'll find typical testing applications for the corks on sparkling wine that require some amount of twist before you pull, and then on ROPP or roll-on pilfer-proof caps on wines and so on, and then obviously more commonly and generally plastic or aluminum caps on PET or glass bottles. So these will be your more commonly used, especially in closure, opening, or application torque style testing. Now, there also is, and I always, again, every time we've talked about torque testing in our industry, once you separate ourselves from vehicle torque, the next step also becomes, oh, do you only test torque on containers? No, not at all. If you think of anything that can twist, things like catheters or automotive knobs or electronic knobs, large mason jars, torque screwdrivers, wiper controls, so anything, if you've looked at the antennas that go on the back of your vehicle, it takes a certain amount of torque to screw it into the base. So those are all different types of samples that we would test in a typical torque testing application. So for those, the kinds of fixtures that you would see are 3-jaw and 4-jaw chucks that are formed specifically around those. And also you would see some typical sockets, that are used 3/8 or 1/2 inch or different sizes, whether it's metric or standard types of sockets that are used that form around the type of sample you're testing. These are usually ideal when you're performing verification tests for torque screwdrivers or torque wrenches and so on. So again, typical testing applications would be in the electronics industry, the automotive, and so on. So again, these are all the types of torque testing fixtures that you would encounter in any torque testing applications. So that essentially completes our discussion of the common fixtures that are usually used in compression, tensile, and torque testing. As I mentioned before, today's presentation is more of an essentials or fundamentals. In the future, we'll look at doing more comprehensive webinars that actually delve into the different types of testing applications that you'd find in compression testing, things like burst or compressive or top load, puncture, needle insertion, and so on. And in tensile testing, for peel and adhesion testing, whether it's 180-degree or 90-degree testing, and also for torque testing, we'll actually look at closure and release torque depending on the types of samples. And what we usually do in any of these more comprehensive webinars is we also do a live presentation where we test actual products to give you a better visual of how these samples are usually used in any of these testing applications. So, and with that, I'm going to turn you all over to my colleague, Sharon, for any questions you may have. Sharon?
Thanks so much, Moses. Just please take a moment to just collect your thoughts. And if you have any questions and have not yet submitted them, you can just put it in the question box right now or in the chat box. And just while we are waiting for some questions to come through, a reminder that our next webinar is taking place on the 31st of October, and it will focus on understanding catalyst and pellet crush testing. So we really hope to see you there, and I will, when we send out the on-demand recording for you, we'll also add in a link there so that you can register for that. But there is some questions that are coming through, so
okay.
I am going to read them to you. So okay. The very first one is, do you have a crimp receptacle that is rated for bigger wire crimps, 2 OT and 4 OT, specifically 20 kilonewton rated?
Excellent question. So it depends. There are crimp receptacles that will go probably down to 2 gauge. Anything in that 2-aught, 4-aught region is probably going to be more of a custom testing application. So we could essentially create a more dedicated crimp receptacle for just those two, where you could essentially have a quick change adapter or a quick change style fixture that's dedicated to those larger cables. We've done this in the past. Now, depending on the type of connector, whether it's a ferrule style connector or it's a typical style connector, there might be additional options out there, whether using a wedge grip, for instance, to grip on the flat side of the connector and so on. So they do not always necessarily have to use the crimp receptacle. I get the allure of the crimp receptacle, the ability to just spin, find the appropriate slot. It makes things a whole lot easier. But as I mentioned, for larger cables, if there's nothing currently existing, we're happy to look at a custom feature or a custom solution. So if this is something you'd be interested in, please feel free. I have my email on the screen, Moses Darocha at PPT Group. Reach out to me, and then we'll be happy to answer those questions a little bit more directly. Back to you, Sharon.
I think you've answered this in part already, but somebody just asked, what do I do in the case that none of my fixtures work on my test sample?
Okay. Yeah. So this sometimes it might be a question of, as I mentioned, so if you take, say, vice grips, right? If you're using vice grips and you're testing, say, a soft material and either the sample keeps slipping or it keeps tearing, then you might probably look at the different set of jaws. Is it because you have serrated jaws? Is it because you have flat jaws? Are you better off using rubber face jaws that prevent that slippage from happening and so on? So again, if you could reach out, we'd be happy to look a little closer at the types of, again, after over 20 years of doing this, there's always going to be a few examples or samples or applications we've done in the past that might actually essentially allow us to answer that question a little bit more appropriately. Say, hey, yeah, we've dealt with a customer, that had similar samples. This was the solution we recommended, and so on. So please feel free to reach out. As I said, we're happy to do this. Another thing we do, a service we do provide as part of our sales process, is we do some pre-sales sample testing. What that entails is if you sent us some samples, what we would do is match them with the most appropriate combination of tester, if you don't already have one, fixtures, software, and then kind of bring you down to the best possible solution that works for you. So if you'd like to ship some samples over to my attention so we can try to match them with the most appropriate fixture, we'd absolutely be happy to do that for you. Back to you, Sharon.
Thanks, Moses. We don't have any other further questions, but as Moses has said, if you think of anything after the webinar that you'd like to discuss with somebody, please feel free to reach out to him and he would be able to assist you. Like I said, we'd love to see you on for the next webinar that's going to look at pellet and catalyst crush testing on the 31st of October. But for now, that's all we have for you. And thank you very much for joining us today.
Thanks, everybody.
Thank you.